What if I told you that there's this one single piece of technology that's, well, it's quietly powering a massive chunk of our entire digital world? It's a language that for decades has been the invisible engine behind everything from your phone to the global financial system. Today, we're going to pull back the curtain on Java. And when I say a massive chunk, I am not kidding. We are talking about the code that runs the entire Android operating system. It's the absolute backbone for huge enterprise applications in banking and retail, and it's what crunches the numbers for big data and scientific computing. So yeah, Java isn't just some programming language. It's practically a global infrastructure. So that brings us to the big question, right? What exactly is this thing? And how in the world did one programming language, born back in the 90s, become so dominant and so essential to pretty much everything we do today? Okay, let's get into it. To really get why Java was such a big deal, we got to go back in time. Think early 1990s. If you were a software developer back then, the world was, well, it was a divided and incredibly frustrating place. Just imagine you've built this amazing new app. That's awesome. But here's the catch. The code you wrote for a Windows computer, totally useless on a Mac, or on any other kind of machine, like one running Solaris. You had to basically rewrite and recompile your entire program for every single platform. It was slow, it was expensive, and honestly, it was a giant headache. But over at a company called Sun Microsystems, a small, really forward-thinking team decided, you know what? This problem is worth solving. And so they set off on this quest to create a single language that could finally bridge that digital divide. So it all kicked off in 1991 with the Green Team. Now, their first goal was actually to build a language for smart electronics, like TV set-top boxes. They called their little project Oak. But by 1995, with the internet just starting to explode, they realized their creation had way bigger potential. So they needed a new name. And inspired by the insane amounts of coffee that were fueling their work, they landed on Java. Just a year later, in 1996, they released the first Java development kit to the world. And this quote just says it all, doesn't it? It shows their ambition perfectly. They weren't just building another tool for programmers. They were trying to start a revolution. They wanted a name that felt alive and fun and dynamic. And yeah, Java absolutely fit the bill. So what was this big revolutionary solution? Well, it was a really simple but elegant idea that they captured in a motto that would change software development forever. Write once, run anywhere. That was the magic trick. It meant a developer could build their application just one time, and that exact same file could run on a Windows PC, a Mac, or a big Unix server with zero changes. This promise, this idea of platform independence, was the absolute game changer. So how'd they pull it off? It's actually an ingenious little process. First, the developer writes their code. Simple enough. Then, the Java compiler turns it not into machine-specific instructions, but into this universal format called bytecode. And that bytecode, well, that's the secret sauce. From there, a special piece of software on each computer takes over. So what on earth is this bytecode? The best way to think about it is like a universal master key. It's this middleman language that no single computer actually understands on its own. It's not a Windows key or a Mac key. It's a generic key that can be used to open any lock, as long as you've got the right locksmith. And that locksmith is the Java Virtual Machine, or the JVM. Any computer that wants to run Java, doesn't matter if it's a Mac, a PC, or a server, has its own special JVM. This JVM basically acts as a personal, real-time translator. It grabs that universal bytecode and translates it into the specific native instructions that that particular machine can understand and run. And that, right there, is what makes write once, run anywhere a reality. But Java's big innovation wasn't just about running anywhere. It was also about how you organized your code. It really championed a philosophy called object-oriented programming, or OOP. So before OOP came along, a lot of programming was function-oriented. You can think of it like a super messy workshop where all your tools and data are just thrown into one big pile. Any function could just grab any piece of data, which, as you can imagine, could lead to a ton of confusion and bugs. Java's OOP approach is totally different. It's more like working with a set of organized Lego bricks. Each object is its own self-contained unit that holds both its own data and the specific actions that can be performed on it. A really key principle here is called encapsulation. This is basically the idea of bundling related data and the code that works on it together into one neat little package. It's kind of like putting a pill and its dosage instructions inside a sealed capsule. The data inside is protected from the outside world, and you can only get to it through its designated methods. It makes your code way more organized and a whole lot more secure. And then you've got inheritance, which is just incredibly powerful for reusing your code. It lets you create a new object that automatically inherits all the characteristics of a parent object. So for example, you could have a general book object, and from that you could create a more specific textbook object. The textbook automatically gets everything a book has, like a title and an author, but then you can add your own unique stuff, like a subject or a course number. It's just a really elegant way to build things. So, you take this revolutionary run-anywhere idea, you combine it with a powerful and organized way to write code, and what do you get? Well, you get a technology that basically went on to build the modern world. And you can see that success in its incredible staying power. For decades now, Java has consistently been one of the most popular and in-demand programming languages on the entire planet. Its reliability and its versatility have helped it stay on top, even as tons of newer, flashier languages have come along. And its legacy is literally all around us. Like we said at the start, it is the foundation of Android. It runs those massive, secure systems for banks and e-commerce giants. It powers web servers, scientific research, and even the tiny smart devices in the Internet of Things, which amazingly fulfills the original vision the Green Team had all those years ago. In the end, Java took off because it solved a huge problem with a really smart solution at exactly the right moment in history. It made life so much easier for developers, and it enabled this interconnected, cross-platform world that we all just take for granted now. Which leaves us with one final thought. In a tech world that changes in the blink of an eye, what does it take for a technology not just to survive, but to keep on thriving?